All right, geometry, last but not least, the third video for lesson 9.1. All right, so it says, is ABCD a trapezoid? So if I take a look here, a trapezoid, by definition, right, a trapezoid has one pair of parallel sides. So we need to remember that to find if sides are parallel, you have to use slope. So the question is, and if I look at this picture, the two parallel sides would probably be AD and BC, right? So the question is segment AD parallel to segment BC? Well, again, we have to find slopes. So let's find the slope of AD. So AD is here. I'm going to go rise 1 up and run 2 to the right. So up 1, right 2, that's a slope of 1/2. I'll do the same thing with the slope of BC. I'll just count my rise up 3 and my run 1, 2, 3, 4, 5, 6 to the right. Up 3, right 6, which simplifies to positive 1/2. These two segments have equal slopes. And if they have equal slopes, that means they are parallel. That means that segment AD is parallel to segment BC. And if segment AD is parallel to segment BC, then this guy is a trapezoid for sure. All right, next one. Now let's see if this JKLM is a kite. So again, I love that this follows the polygon, the quadrilateral chapter, because we can remember all those special ideas. So now a kite has two pairs of consecutive congruent sides. Consecutive. So that means two pairs, one right after the other. So if you look here, looks like KL and LM should be parallel. Or I'm sorry, congruent, not parallel, congruent. KL and LM. And then we're also looking at the bottom two, which would be JK and JM. So this is going to require all four distances. Okay. Now, if you do two and they're not congruent, then don't do the others. You could stop. But if you find the first two are congruent, then you got to keep going. Okay. So let's do KL first. I'll use different color for each one. So for KL, I'm using the distance formula, which is where I create my right triangle, right? Find my horizontal distance 1, find my vertical distance 3, and I'll take 1 squared plus 3 squared in the square root. And that's the square root of 10. Now I'll do the same thing for LM in blue. So I'll create my right triangle, 3, 1. That is going to be 3 squared plus 1 squared, and that is the square root of 10. So they are congruent. So from here, I know that KL is congruent to LM. So I'll keep going, right? If that was not the case, I would have stopped and said not a kite. All right, let's do purple. Let's do JK. Okay, I'll go from K to J. I'll go, or I'll just create my right triangle. So there's my right angle. My horizontal is 4. My vertical is 3. So I'm going to do 4 squared plus 3 squared in the square root. That's the square root of 25. If you care to, that equals 5. Right? And now if you look at JM, JM is actually vertical. So you can just count, right? There's no rise and run. There's no right triangle. It's just vertical. So just count from J to, I don't care. 1, 2, 3, 4, 5. So JM is 5. It's just vertical. So it is important that you simplified the square root of 25 to get 5, because now you see that they're both 5. This means that JK is congruent to JM. You just showed that this quadrilateral has two pairs of consecutive congruent sides. Therefore, it is a kite. Great. Okay. All right. I got one more problem here. It's got two parts. So it says Dylan draws up a plan to fence in a yard for his chicken. The distance between grid lines is 1 foot. So that's your scale, right? So everything is 1. Okay. Is 30 feet of fencing enough to enclose the yard? So it looks like he's going to make a triangular fence, which is interesting. I mean, good for him. All right. So let's find the three distances AB, BC, and AC. Because if you want to enclose a yard, you got to look at the perimeter. And that's going to require all three distances. So let's do AB first. I'll use red for AB. So from A to B, I got to go right triangle. Vertical 1, 2, 3, 4, 5, 6. Horizontal 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to do 8 squared plus 6 squared. That is going to be the square root of 100, which is a nice number of 10. So that's 10 feet. Okay. Then I'll do BC in green. BC is vertical. So you just count it. Love it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So BC is also 10 because it's vertical. So that's 10 feet. So then I'll do AC in blue, create my right triangle. Vertical is 4. Horizontal is 1, 2, 3, 4, 5, 6, 7, 8. So that is going to be AC, which is 8 squared plus 4 squared. That's going to be the square root of 80. And because I'm comparing it to 30 feet, I'm going to go ahead and round that, right? So the square root of 80, if you type it in Desmos, you get about 8.9. So now I'm going to add those together to find the perimeter. So the perimeter would be 10 plus 8.9. And that would be a perimeter of 28.9. You need 28.9 feet, which is less than 30. So is 30 feet enough? Yes. Great. Okay, last but not least, part B. Now it says, for a healthy flock, each chicken needs at least 8 square feet of space. What is the maximum number of chickens Dylan can put in the yard? So each chicken, so one chicken, needs 8 square feet of space. So what we have to do is we have to find the area of this space right here, find the area, and then divide it by 8, right? Now, we could actually find this area directly because if you look at the triangle and use this vertical side as the base, you can actually connect the left vertex down to that base, and that would be your base and height. Okay, so that's the shortcut, right? So area would be base and height. But I'm going to do it a different way, just in case you don't have a vertical or horizontal side. I'm going to do it using the rectangle. I'm going to enclose, just like we did in the last problem, I'm going to enclose this right triangle this triangle into a rectangle, like so. Right? I'm going to connect those. I'm going to connect these. So what we're going to do here is we're going to find the area of the big rectangle. So remember, area of the rectangle is base times height. And then I'm going to subtract these two triangles, 1 and 2. If I take the entire area and subtract 1 and 2, then I will have the red area left over. And what's nice about triangles 1 and 2 is that they are right triangles. So the legs are base and height pairs. Base, height. And we can easily find the area. So again, I'm doing it this way because not all triangles that are drawn have a horizontal or vertical side to use as a base. Okay? All right, so let's find the area of the rectangle. So the area of the rectangle is going to be this outside. It's 10 by 1, 2, 3, 4, 5, 6, 7, 8. 10 by 8. So 10 times 8, that's 80 feet squared. Okay, so now I'll do blue. Let's find the area of triangle 1. So triangle 1 is this one here, has a base of 1, 2, 3, 4, 5, 6, and has a height of 8 again. So we're going to do 1/2 times 6 times 8. That's half of 48, which is 24 feet squared. And then I'll do triangle 2 in orange. So the area of triangle 2, again, 1, 2, 3, 4 is this side length, this leg, and this other leg is 8 on the bottom. So we're doing 1/2 times 4 times 8, half of 32, that's 16 feet squared. So to find the area of my red triangle, I'm going to take 80 minus 24 minus 16. That's 80 minus 40, which is 40 feet squared. So I have 40 feet squared in this triangular region to then distribute amongst flock of chickens. If each chicken needs at least 8, I'm going to do 40 divided by 8, and that's 5. So he can have at most 5 chickens. Notice I say at most because each chicken needs at least 8 square feet. So 5 times 8 is 40. No more chickens can be in that space. All right, so hopefully this lesson went well. Big time OST stuff here. Finding perimeter area using coordinates. All right, thanks for watching. We'll see you in class.